I have it written in our Excel document, but
Oh, I have the, wait, this is uncertainty?
Well, it eventually will be, right? Well, let's start with the original expressions, right?
Okay.
just regular.
I have 8 equals big fraction g times in parentheses
Oh, it's this one.
m1 or sorry m2 minus m1 sine theta all over m1 plus m2.
M1 what, sorry?
m1 plus m2.
Something like that? Will that look about right?
Yeah, that's right.
Okay. All right, so the point is then that we want to get UA. And what I'm going to do is I'm going to check to make sure the units work out, right? Yeah, both the parentheses things are masses, right? So they cancel, leaving me with G, which is an acceleration. So it'll have the units of acceleration. So at least unit-wise, that makes sense. All right. So barring any typos in A, let's do this. How many of the variables in A have uncertainties? 3. Does M2 have an uncertainty?
Yeah.
Sure.
M1 does as well, and so does the A.
And I would assume that M1 does too, for similar reasons. Theta?
Yeah.
Sure. G?
No.
Yeah, we're going to assume that G's uncertainty is so small that it's not going to matter. Okay. So if we do that, then we have a, how many term expression down here?
3.
3, right? There's going to be one for each of the variables. So starting with, I don't know, M2. Let's go left to right. All right, so derivative of that with respect to M2. Couple of ways of doing it. I'm just going to do it the hard way, which is using what rule? I got to take the derivative of this with respect to M2.
Quotient.
It's the quotient rule. Yay. Right, because I got an M2 up and I got an M2 down. Nothing I can do about that. I can't separate it out and cancel it or anything, right? So, yeah, just bite the bullet and do it. Okay, so, well, let's see. Fortunately, the denominator's always easy in the quotient rule, right? It's just the denominator squared. Okay, so that's not so bad. All right, then it's V du minus U dv, right? So V is going to be what? Well, it's going to be, I can pull the G out of the whole thing, so I'm not going to worry about this. So I'm looking just at this. So actually, yeah. Does it matter? It doesn't matter. Yeah, so basically this is V, this is U, right? U is the numerator, except for the G, and V is the denominator. Everybody okay with that? Okay. So V du is going to be that times the derivative of that with respect to M2. And it's just simply what?
1.
1, right? Because that don't matter, right? Okay. Minus U dv, so it's M2 minus M1 sine theta. Let's see. Now the derivative of this with respect to M2 is again 1. Okay. So it's not so bad. I mean, it's kind of horrible, but the 1's go away, right? And it looks like the M2 is going to cancel the M2, right? So you can simplify it. It's not so bad. The units will still work out because I've got a mass and a mass. That's mass squared on top, mass squared on the bottom, so that's okay. And I still have a G, so that means that it's still acceleration. All right. How different is the UM1 expression going to look? A little different, but not a lot, right? I'm still going to have a G that I can pull out. I'm still going to have M1 plus M2 squared on the bottom, right? And then V du again is going to be V, which is M1 plus M2. Now, the derivative of this numerator with respect to M1 is just what? It's not 1 anymore, right?
Sine theta.
Right, it's not just sine theta, it's
It's
minus
negative
sine
sine
theta.
theta.
So it's minus sine theta. Okay. Minus V du, U dv, which is M2 minus M1 sine theta. Okay, now the derivative of the bottom is still 1 with respect to M1, right? It's 1. Now I don't get any nice little cancellations, I don't think, right, cause I got the sine theta over there. Oh wait, no, I can actually cancel.
Negative, yeah.
No, it's minus, oh, and that's plus.
Yeah, it is.
Right, so I can get rid of that one. Alright, so it does simplify a little bit, right, okay? Alright.
That's wrong.
And then finally, yay, I better make the square root much bigger. There we go, plus u theta. Okay, this one's easy, right? It's not a, there's not a theta on the bottom, so this is just straight up derivative, right? So what is it? Yep, so does the M2 matter? It does not. It's gonna be minus M1 cosine theta over M1 cosine 2. Check the units, masses cancel masses, that's unitless, I've got an acceleration, we're all good. Okay,
Actually got really close.
what do you think? Yeah, I mean, you could basically do the uncertainty of this and then the uncertainty of that, and then just have two uncertainties, but this isn't terrible as things go, right? So I just did it that way.
It's not as bad as the tension one.
Yeah, it's not as bad as the tension was, right? So by the way, what units does this have to be in? Radians. Right. Yeah, the other angles don't matter, right? Because they're all going to be signed or cosigned, right? So it doesn't really matter. But basically, that one has to be in radians, otherwise this term will be too big.
Wait, so
Yeah.
for the cosine theta, you don't have to turn that into radians too, you can keep it in degrees?
Cosine of like pi over 2 is still 0.
Okay.
Yeah.
Okay,
Yeah.
okay.
Yeah.
So
I
don't
mean, it
matter.
just depends what you think your program needs. Excel will require radians, so you do have to convert all
Yeah.
angles into radians. On your calculator, though, you can set your calculator to degrees, right? You don't have to worry about it.
Yeah, yeah.
That's sort of ominous, isn't it? It's like, wow. All right, considering it, I guess it's a good reminder, but still, you know, that was a little startling to see that. Okay. Anything else? Mike, second up.